Hey, everybody. So I have some good news and I have some bad news. The bad news, Google I/O is almost over. We're all going to have to go back to our day-to-day lives very soon. The good news is there's still enough time for me to tell you a bit more about progressive web apps. Now, that slide doesn't really do it for me. There's still enough time for me to tell you about progressive web apps. Yeah. Now, I'm really excited about progressive web apps because I love the web. The web is the biggest, most important distribution platform on the internet. It democratizes content and lets anyone publish their content, publish their idea to anyone else with a super low barrier to entry. But of course, mobile is very important. And the web experience on mobile hasn't always been great. But progressive web apps are here to help us bridge the gap between where we wish mobile web was and where it is. And you may have heard a lot of things about progressive web apps, all of these technologies that go into it, all of the different things that make it up. But really, progressive web apps boil down to two key ideas. You need a first-class mobile experience for your site. That means that if I'm looking at a site on a phone, it feels like it belongs on that phone. It has nice big touch targets. It feels like it belongs on the system. And the other thing that's kind of unique to progressive web apps and is available for the first time to web developers is that you need a first-class connectivity experience. So whether I am at home on blazing fast Wi-Fi powered by Google Fiber, or I'm in a subway somewhere with no connection at all, I should still be able to get access and benefit from web applications. And really, that's not something that's been possible for a long time. But really, progressive web apps, it's not some separate thing. It's not some totally separate system that now we're buying into. And before I built web apps, but now I build progressive web apps. Progressive web apps are just a new set of practices and technologies that help us build good web apps. And of course, picking technologies for building web apps is pretty hard. There's tons of things out there. It's hard to know exactly what to pick, who to use, why to pick this stack over another stack. And as you might notice from my shirt, I'm a big fan of Firebase. Firebase is an integrated suite of products that help you develop your applications, grow your user base, and earn more money. And for web applications, Firebase can save you a lot of time and hassle of choosing what's the right way to do X or what's the correct thing to do for Y. So let's say that I have an idea. I want to build the world's first 100% emoji-powered team collaboration app. I'm really excited about it. And then I go to Jake Archibald to talk about service workers and realize that maybe it's the world's second 100% emoji-powered team collaboration app. So I need to move quickly. I need to be able to build something and get it out there so that EmoJoy doesn't run away with all the users that I want. So I might integrate with Firebase Auth so that users can easily sign in using their Google, Facebook, GitHub, Twitter, or email and password credentials and get into my app quickly. And then I need a place to put all that application data. So I'll use the Firebase real-time database so that no matter what client is whenever any user changes data in my system, it's instantly synced to all other connected devices without me having to write complex polling logic or anything else. Firebase Auth and Firebase Database make it really easy to quickly build powerful web applications. And now I need a place to put that web application, so I might want to deploy it to Firebase Hosting. Firebase Hosting is a static web hosting service that lets you deploy your site to a global CDN with a simple command line invocation. It takes just a few seconds, and it's really easy to get started. So now I've built my web app, and I've got some idea of what I'm doing, and I've deployed it to Firebase Hosting. So let's take a look at my web app. So this is Teamoji. Need to start a web server here. So Teamoji is a simple web application built using Firebase and Polymer, which is Google's library for helping you build web components and integrate them into your applications. So if I refresh here, you can see I have Teamoji. And I'm going to sign in with Google. Oop. The demo gods are already against me, but it's going to be all right. Here we go. So I've signed in with Google, and as you can see, I can see my team's status updates, and I can update things. So since I've already had like 2 demo failures, I'm feeling a little nervous right now, and I want to let my team know that. Now I can also create a new team, so let's say, let's make a Google I/O team here. All right, so I've made my Google I/O team, and I'm feeling a little bit better because it hasn't had another train wreck just yet. So this is my application, and it works pretty well. If I'm a web user and I access this, whether it's in a browser simulating a mobile device or on a real mobile device, it's going to be a pretty good experience. But what happens if I go offline? Well, that's not a great user experience. In fact, that's not any user experience. My app is completely gone. And you might have heard a lot about offline first with regard to progressive web apps, but that's not really the only important thing because, believe it or not, connectivity is pretty good in a lot of places, or at least it's good enough. So you're not going to be offline much of the time, but there might be a pretty good, significant portion of the time that you don't have the best connectivity. So let's say that I have just a regular 3G connection, and I want to load my Teamoji app. And I'm going to have to vamp a little because this takes actually a really long time. So low connectivity and web applications traditionally haven't mixed very well. That was maybe 10 or 15 seconds to load my web application, and that's not really acceptable to my users. If I hit that every time I want to go update my emoji status, no one is going to adopt my application. So we need to use new technologies to make this a better experience. Right now, I have my web application. And like I said, there's nothing wrong with existing web applications and existing technology. If I have a good internet connection, I can build a web app that leaves my users feeling really happy much of the time. But we can do more. We can integrate our web application with the platform a little better so that I get things like a nice icon on my home screen or a splash screen when I'm loading. And now my users feel more like, hey, this was designed for mobile. This is something that I can use. We can go even further and cache our application shell so that the bare bones and the Chrome of our application are ready nearly instantly as soon as we boot the web application. And now my users are really happy because that's what they really want. They want the app to be fast. They want it to work where they go. And then we can take it one step farther and actually make your application data offline so that even if they have no connectivity at all, they can still use your application. And that makes them so happy they turn into a cat for some reason. So I'm talking about progressive web apps, and something that I really want to emphasize is that progressive web apps, believe it or not, are built progressively. This isn't something that's all or nothing. You don't have to do everything that I'm talking about here today all at once and spend months developing it and then do some big bang launch. Each of these technologies can be implemented piecemeal, one by one, adding new features to your web application, making it a better experience on mobile, and making your users more happy, because that's really what it's all about. And so you know what? Forget what I said earlier. Progressive web apps aren't just a way to build good web apps, because we could already do that. Progressive web apps are a way to build great web apps. And so how do we achieve that greatness? Where do we go to get from where we are today to a great progressive web app that works in all of these situations? Well, something that I want to sort of emphasize and remind you is that users don't care what technology stack you use to build your application. They don't care which framework you choose. They don't care even whether it's a native or a mobile app. For users, if it looks like an app, if it feels like an app, it's an app. That's all there is to it. They just want a good experience. And so what we're going to do today is we're going to take this Teamoji app and we're going to add better and better experiences so that it becomes a first-class mobile application. The first thing we're going to do is really easy. We're going to add a web app manifest to our application. Now, a web app manifest is just a new standard that allows you to provide some JSON metadata about your application so that browsers and operating systems can pick that up and use it for various hints about how to work. So here's what it looks like. We have a JSON object. We add a name and a short name. So the short name will be used under like an application icon on the home screen. The name might be used on the splash screen as it launches. We have a theme and background color. The theme color is going to go into the title bar on Android when you're in your task switcher. The background color is going to be the background of your splash screen as the application launches. We have some configuration about display and orientation. So the display mode is essentially, when I launch this app, what do I want it to feel like? Standalone is sort of the closest analog to a standard native mobile application. It launches in its own window. There's no browser Chrome around it. You can also do a full screen mode if you're building a game, or you can bring browser UI in if you haven't completely converted to an app-friendly UI. And then finally, you want to provide icons, and you have to provide a big array of icon sizes to support all the different platforms and everything they need. And that's kind of a hassle. And honestly, remembering the names of all of this stuff and what I have to do, also kind of a hassle. So I built a little tool called the Web App Manifest Generator. It's available at appmanifest.firebaseapp.com, and I'll take a quick moment to show you what it looks like. Here it is. We can put in Teamoji, team status. Put in my name, my short name. Let's see, I want a nice material design amber for this. I think that's what I'm feeling. So I'll paste that in. I want the standalone. This app is designed for portrait mode. And then finally, I just need to pick an icon. So I'll pick my logo. And this will generate a zip file that contains your manifest.json as well as resized icons for all the different sizes you're likely to need. Again, this isn't a complicated tool, but it saves you some time, makes it easier to get started. You have literally no excuse to not add a web app manifest to your application. So I'm going to install this web app manifest, and what is the result? Well, if I look at my web app on my phone after installing a web app manifest, I'm going to see a home screen icon if I do add to home screen. I'm also going to get a home screen install banner if I use a web app manifest and some of the other technologies we'll be talking about in a few minutes. If I load the app, I see this nice splash screen. So rather than just a blank white page of Chrome trying to load the app, I see this nice splash screen that waits until the application has started loading to kick it over to the browser. And I see this nice themed title bar. So with just a few minutes of work, just adding a JSON file into our application and then referencing it in our HTML, we have already made our app feel a lot more at home on mobile. So now our users are a little happier. And what's next? Well, you may have seen a statistic recently that the average website is now as big as the original Doom game from the early 90s. It's a little bit over 2 megs. So every time you go to a website, on average, you're going to be downloading 2 megs worth of content. And that sounds like a lot. And it is a lot, but I want you to keep something in mind. Web apps are kind of held to a higher standard here. If you look at the top 3 applications in Android, each one of those is over 30 megs. You install those, that's 15 times the average website. So web apps are held to this sort of different standard because traditionally, every time we go to the web app, we're loading all that content again, unless we get really lucky with recent browser caching. So of course, there has to be a better way, and there is. We can offline our app shell. Now the app shell, if you've built single page applications, that's just all the JavaScript, HTML, CSS, and images that make up your web application's Chrome. Not the user data, but just the stuff that needs to bootstrap in the browser for your application to be able to run. And if we want this to be available offline so that our users have a fast experience even with slow connectivity, we're going to use Service Worker. So Service Worker is a new low-level browser primitive that allows you to install a JavaScript that runs in the background whether or not you have a web application open. If you do have it open, it runs in the background. You can pass messages. If you don't have it open, the Service Worker can intercept network requests and decide how to handle it. So it can intercept a request and say, oh, hey, I have a cached version of this locally, so I'm going to serve that up instead. And you can do really cool, really complex offline tasks using Service Worker. And there's only 2 things you have to do to be able to use Service Worker. First, you need a secure connection. Service Worker only works over SSL. It also works on local hosts, so you're not totally in trouble if you're doing local development. But if you're deploying to a production server, it has to be running SSL. The other thing that Service Worker needs is a complex understanding of browser caching and networking semantics, and then how to write all that code so that it handles it properly. Service Worker is not simple. It is powerful, it is not simple. And that's actually great, because Service Worker gives us powerful primitives that we as developers can build on top of to make an easier experience. So how do we get these two things that we need? Well, first of all, if you need a secure site, I highly recommend Firebase hosting, because as of Google I/O, you get a free custom domains with SSL. Bring your own domain, we'll provision a certificate for you. You don't have to do anything, it all just works. So I'm pretty excited about that. I've wanted it for a long time. The other thing that you can use is a library called SW Precache. This is an open source node library that basically gives you an easy way to generate Service Worker JavaScript. So this is a task that you would run in your normal web app build process that'll generate a Service Worker for you and do most of the heavy lifting to get your app shell ready to go offline. And there's two types of data that it caches. It caches static files, so that would just be your actual application files in your project directory, all the JavaScript, HTML, all that stuff. And it also caches remote files. So if you're using fonts from Google Web Fonts, or you're loading images from a CDN, or JavaScript libraries from a CDN, you can cache those on demand using SW Precache as well. So first, let's take a look at how we cache static files. Here I'm using Gulp as an example because it's popular, but SW Precache is just a node module. You can install it in any build system or just run it independently as a command line tool. So I'm defining a Gulp task called generate service worker. And I require my SW Precache library, and now I call swprecache.write, and I just point it to the service worker JavaScript that I want to generate. It's important to note that the service worker should always be in the root of your web application, because service workers are only able to do work on things that are at the same level or lower in the browser hierarchy. So you always want to put this at the root so that your service worker can do everything you need it to do. Next, I give it a cache ID, which is anything you want to call it, but probably the name of your app. And I provide a list, a glob of the static files that I want to cache. In this example, I'm picking pretty much everything from my build directory. You may or may not want to do this depending on the size of your application. There are limits to service worker caches, and really big ones will have things evicted. So you're going to want to sort of tune this and play with this until you have just the right stuff to bootstrap really fast. And then finally, we strip the prefix dist so that the URLs all work because our build directory is dist. It's no big deal. The other thing that we need to do is register the service worker. So first, we're going to detect if the browser has service workers, because of course these are progressive web apps. We want to build progressively. We don't want to break browsers that don't support it yet. If we do have service worker, then we just call navigator.serviceworker.register and point to our generated service worker. This returns a promise that will complete when the service worker is registered, or of course we can see if any errors happened and deal with that as well. So this is really the simplest way to get started with Service Worker. And now we've cached our static files offline by generating a Service Worker with SW Precache, and we've registered it in the browser. The other thing we can do is cache remote files. And this is just adding additional configuration to SW Precache for runtime caching. So here's an example of I want to cache anything from fonts.googleapis.com, and I want to use a cache-first strategy. So cache first means that, well, web fonts don't change very often. So I can always depend on the cached version because I don't expect the network version to be any different. And that makes it really fast. That means it's going to respond from the cache immediately. However, for other things like profile pictures or Firebase storage URLs from things you've uploaded, those things might change. And so you're going to want to use network first. And network first just says, go to the network. If I get a response, use the networked response. But if I don't, use the cached response. And that's what allows it to work offline. So that's SW Precache. That's caching our app shell offline. So let's add this to Tmoji. I'm going to go over here and pull up my Gulp file. And the first thing I'm going to do is define my Gulp task. And again, this is exactly what I just showed you with a little bit more configuration, but nothing too different. And I'm going to add that into my build process. So generate service worker. Can't spell. So now that's in my Gulp file. And of course, I need to register it as well. I have this app.js, which is loaded immediately on page load. And so I'm going to register my service worker in here. And I've added a little bit of extra logic here. So one of the things that you may have seen if you've used Google Inbox or other progressive web apps is that sometimes they'll pop up a little notification that says a new version is available, click to refresh. And that is what we're doing right here. So we can detect if a service worker was already installed and has just been upgraded, and we can display a message that says, hey, there's a new version, you might want to refresh. Or if it's the first time, we can just let people know, hey, Teamoji is now offline ready. So now we have added this to our gulp file. We've added it to our application JavaScript. Let's build this and see what happens. So I'm going to go back over here. I'm going to use my full network connection to get the first page load. And now you can see at the bottom, Teamoji is now offline ready. And now let's say, I'm out and about and I'm not on a great connection. I'm on, well, GPRS is a little harsh. Let's go with regular 2G. So I'm going to refresh my page. And you can see that loaded up in a couple of seconds versus the 15 seconds it took before. So by adding a few lines of code to our, oh, sorry, if you want to applaud, go ahead. So with a few lines of code in our gulp file and a simple service worker registration in our app JavaScript, we have now made our app way more usable on poor connectivity experiences. But our app isn't going to work completely offline yet, because all we're doing is caching the shell. So what comes after this? Well, of course, oh, sorry, now our users are happier, moving on. Of course, the final goal of this is to have that truly first-class experience. And if you can have offline data, if your application can work when there's no connectivity at all, then your web application stands toe-to-toe with world-class native applications. There's no difference from your user's perspective. They can use it offline, it's snappy, it's responsive, it's all of the things that they're looking for, and you don't have to go native to get all of those advantages. So finally, we're going to offline the data in our application. And to do that, we're actually, quick caveat before I continue, this is the part that is most app specific. There's different strategies that you might want to use when you go offline. For some applications, you might need to store a draft of a document, and then when you go back online, you sync it. For other applications, and many applications, all you really need is kind of a view of what they were last looking at, and that's useful enough. So for this example, we're going to use a read-only offline cache. So as I described, all of my data is in the Firebase real-time database. And ordinarily, what I would do is take that data and display it directly in the browser. But in order to support a full offline reload situation, I'm going to put one step in the middle. I'm going to add an IndexedDB mirror. So I'm going to take all that data from the real-time database. I'm going to mirror it locally into IndexedDB, which is an offline database that's available in most browsers. And then I'm going to use the browser only to access that offline mirrored data. By using the browser only against the IndexedDB data, that means that when I'm offline, the browser doesn't know the difference. It's just reading the same data that it was already reading. But when I'm online, I can use the browser to push directly into Firebase and update my changes. So this is a relatively simple thing to implement, but offers powerful features by mirroring all of your data locally. And here, I'm going to get a little help from my friends at Polymer. So there's two new things that I'm excited to announce today. The first being PolymerFire, an official set of bindings for Polymer to Firebase. And the second, that the Polymer... The second thing is app storage, which was built by the Polymer team as part of the Polymer app toolkit and provides easy ways to do things like mirroring data offline. So we're going to use these two things together to take our data and make it available completely offline. Let's see how that works. So first, here's how we use PolymerFire. I'm going to import the element into my application. If you're not familiar with Polymer, the link-rel import is essentially a script source you're importing into your application. And then I'm going to use the Firebase app element to sort of set up and configure my Firebase application. All of the data that you need to put into this is available from the Firebase console for your project. So you just take those values, copy and paste them into your application. You put one Firebase app in your page, and then it's initialized across everything. Next, I want to integrate Firebase Auth. So first, I'm going to add a Firebase Auth element into my page. and I'm going to select a provider. In this case, I'm using Google Authentication. And I'm going to bind the user into my application. So the user will be null if I'm not signed in, but it will be various user data if I am signed in. So how do I get between those two states? Well, I implement a simple login function here that calls the sign-in with pop-up method on the Firebase auth element. This mirrors exactly the standard Firebase SDK in JavaScript. And that will trigger a sign-in flow, which will then populate the user, which will then bind into my application, and it all just flows through. So my actual application code is really simple. I can display a welcome message if I detect that if there's a user, and I can display a login screen if there's not a user. Now for the Firebase database, things are also very simple. If I want to sync a document, so an individual document, say I have user preferences and I want to sync all of my preferences into the browser and use those, I use the Firebase document element. I provide a path to the document that I want to sync, and then I bind that data from the data property into my application. I can also use a Firebase query element, which allows me to query collections in Firebase using all of the same query properties that the Firebase database allows, and then sync that data into my path. And so this is how I originally built Teamoji. I used these elements, I built the application, but at this point, it's still not offline, because while the Firebase database supports offline, if you lose connectivity and then come back online, if I hard refresh the page, all of that data is gone because it's just an in-memory cache. So the one extra step that I need to take is to integrate app IndexedDB mirror. So here's my Firebase query element. As you can see, I'm querying updates from a user, the current user that I'm binding into the path. I'm providing some various query elements, or some query properties. And now I'm going to import app IndexedDB mirror from the app storage element. App IndexedDB mirror does exactly what you saw in the diagram. It takes data that gets bound into it, and it creates an offline mirror of it, and then makes that available to the browser, whether or not you have connectivity. And the way that I'm going to do this is, first, I'm going to bind the data from my Firebase query. Instead of into a public variable, I'm going to bind that into a private variable that I'm going to call FB updates. Now I'm going to add an app IndexedDB mirror element, and you can see that this actually mirrors, in many ways, the properties of my Firebase element. I have a key that tells IndexedDB where to store it. And the great thing about this key is that as that user.uid changes, as I'm loading different data, so if I have a switcher where I pick between multiple things, all of that data is going to be cached offline to those different keys, so I can still have that same UI state change and all of that data even when I'm offline. The session property there simply says, if this value changes, we want to wipe out everything. So if I have a user that logs out and a different user logs in, they're not going to see the other user's data. It's all just going to be wiped away. And so what I do with the app IndexedDB mirror is I bind the FB updates variable that I pulled out of Firebase query into the data property. And then for my application, I use the persisted data property, which is the data that has actually been persisted into IndexedDB. And that's really all there is to it. Once I've implemented the app IndexedDB mirror alongside Firebase query, my data is going to be available offline. So let's take a look at that. I'm going to go into my main app element here. And I am going to, so here you can see that the only data that this app needs is some preferences, the updates for the current team that I'm looking at, and the list of teams. So what I'm going to do is I'm going to take all of those and I'm going to replace them with equivalents that have app IndexedDB mirror. And this is just exactly the pattern I just showed you. I'm mirroring into the key, I'm using the session. It's everything that you just saw. And that is what makes my data available offline. Now, one other thing that I'm going to show you here is how to use the browser to detect offline state so that you can change your UI. Since I'm implementing a read-only offline cache, that means that I shouldn't be showing my users a button where they can make an update if they're not able to while they're offline. So here in an initialization function, I'm going to just throw a little JavaScript, and this is just straight from the browser. There isn't anything special about this. The navigator.online tells me if I'm currently on or offline, at least according to the browser. And again, this is no connectivity versus some kind of connectivity. So even if you have the world's worst connection, this will still be online. But it does give you some semblance for when you're totally offline. And then I'm going to listen to both online and offline events and just set a property on my main app element. Now, I've already done some work of wiring in data to change UI state throughout my application. But remember that all I'm really doing to change all of that is setting offline to true or false based on whether I detect that from the browser. So I'm going to save that. I'm going to rebuild my application. And once it's ready, now I am going to refresh. I'm going to turn off throttling for a moment. Oh, and I just refreshed out of it, but you could see for a moment that a banner popped up at the bottom saying a new version of Tmoji is available. Click to refresh. Whoops. Oh. And I missed actually importing the AppIndexDB mirror element, so that didn't work the first try. Let's give it another spin. And server has started. Refreshing. So now you can see I'm online, my data works. I'm feeling a little bit better again. So I'm going to go ahead and update my status. I'm feeling pretty good. And now I'm going to do something that, to me at least, seems like a really bad idea to do in a live demo, and I'm going to turn off my Wi-Fi. So now I'm offline. And as you can see, the UI state pretty quickly changed and reflected, hey, you're offline. But of course, this would have all worked with just normal Firebase SDK JavaScript, because Firebase does keep an in-memory cache, and everything will work fine so long as I don't refresh the page. So let's refresh the page. It comes back online almost immediately, and now my app is fully offline. So that's how we build a progressive web app. And that's how we make users not just like our application, but love it, by providing them the features and the utility that they need, regardless of connectivity, regardless of device. If they use this on the desktop, if they use this on their phone, it's all the same. It all works great. And that's the promise of progressive web apps. So now that we've taken our application to the next level, what do we do after that? Well, there's several things you can do. Of course, you can implement offline write. You can make it so that you can compose data offline, and when you go online, it will sync. And the Polymer Fire App Storage Duo actually does support this. There's a code lab available that'll be linked from the end of the talk that you can go through that'll show you not only how to create a read-only cache, but also how to create write offline data. We can also use the Web Push API. So it's a new standard that allows you to receive notifications whether or not your app is open on the web. You can use Firebase Cloud Messaging to send messages to your browser users, and they will receive that as a native notification from Chrome, and they'll be able to click and re-engage. You can also do a surprising amount of things with the web and phones. There's this cool website called whatwebcando.today. And if you go there, it'll show you all of the device capabilities that your phone's browser is capable of handling. Everything from geolocation to taking pictures to even accessing Bluetooth beacons or the gyro. There's a ton of stuff that I didn't even realize until I saw this site that you can do today with phone capabilities in the browser. And so again, progressive web apps are all about building layer upon layer to make your app experience better, to make your users' experience better, and to make great web apps. So that's all I've got. Thank you for listening. If you're interested in hearing more, I'll be at the Firebase office hours in stage 6 in 15 minutes. Everything that I just presented is available on GitHub. And if you want to talk more, you can also go to bit.ly/pwas on Firebase and chat in the Google space. So thank you.